Okay, so this is a video about naming. So we're just going to do some compound naming. We can create the kind of this flow chart, but that makes life a little bit difficult. So there's three scenarios that you can kind of run into. One, you have a metal combined with a non-metal. Simple, straightforward, metal and a non-metal. Remember, the metals are on the left side of the periodic table. The non-metals are on the upper right. Okay, so metal and a non-metal. Second is you can have a metal and a non-metal. But the difference is metals have variable charge. So there's two different types of metals that we're going to have. The metals can either have a fixed charge or they can have a variable charge. But they're going to have two different types of setups for it. If it has a metal and a non-metal with a fixed charge, we are just simply going to name it. If it has a metal with a variable charge, we are going to name it with a Roman numeral. And we'll get to those specifics in a little bit when we talk about naming those things. Third, the final one is having non-metals and another non-metal. And in this situation, when we have a metal and a non-metal, or two non-metals rather, we are just going to name it, but we are going to add a prefix. So we're going to talk about these three scenarios, and that's all the naming that we need to know. The one adjustment to this is polyatomics. Polyatomics are sets of ions that have a variety of different, basically they always have a certain charge. So polyatomics are just going to have their names present. So just simply, whenever you see you identify a polyatomic, we are just simply going to name based on the polyatomic. On polyatomic. Okay, so in the polyatomics, I'm just going to go through these quickly. There's a group of them. So OH minus and CN minus, those are hydroxide and cyanide. There is one positive one that we're going to use, which is NH4 plus. NH4 plus. This one is known as the ammonium ion, or just ammonium. Okay. And then there's different groups. So we've got those, and then we have different groups for different nonmetals. So SO4, which has a 2- charge, and we have SO3, which has a 2- charge. So SO4, SO3, 2-. The SO4 is called sulfate, and the SO3, so you lose one oxygen, is called sulfite. I have the NO3 minus 1, NO2 minus 1. This is going to be nitrate and nitrite. So again, ite and ate. Okay, one less oxygen, but they all have the same charge. And then the last two I'm going to add to this, CO3 2- is carbonate and ATE. There we go. And then PO4 3- is phosphate. Thing seems to be dying here. Phosphate. Okay, I'm pretty sure that's the list that I provided in class. Those are the basic, simple ones. Those are the ones that you need to know. Okay, in fact, I'm probably going to provide those, but those are the ones that we need to know. So we're just going to have those names available. So these are the three different naming schemes. Okay. And so let's just talk about these two concepts of a variable / fixed charge. Okay. So the idea is, and the best example I can give you is, if we were to name FeO and Fe2O3, Well, we would always start, and so in terms of just simply naming, so before we even get into this idea of variable or fixed charge, let's just talk about naming. So if I were to write out, and this is what we're going to work on, if I have NABR, I don't know, MGO, let's do FEO along with FE2O3, let's do S2O4, and let's do one more, CAF2. So let's just start with those simple ones. Regardless of what type of naming system we use, 1, 2, or 3, we're always going to start the same way. In fact, you don't even need to know which naming system you're going to use before you start to name these things. So you take a look. The first one keeps its name. So in this case, it becomes sodium. And I'm going to leave some space in between the sodium and my next one, because if I need to add anything, because we may have to, then we can add it. So sodium, first one keeps its name. And then, by the way, the first one is always the positive one, which is always the metal, or always the positively charged one. So sodium bromide. Okay, second one, you notice is going to, instead of bromine, this is bromine. I get rid of that and I replace it with this IDE ending. So it's just going to get an IDE ending. So sodium bromide. Magnesium oxide. Again, leaving space in front of both of those just in case I need it. Iron oxide. So the problem here, and this is why this is a good example, this is iron oxide. We also start calling this one iron oxide as well. So we have yet another one, which is iron oxide. We have to be able to, as chemists, we have to be able to differentiate this iron oxide from this iron oxide. So that's why it's important to recognize the idea of fixed versus variable charge. So we're going to come back to this, but we're continuing along. This is sulfur oxide. And then this last one, calcium fluoride. Okay, so again, what we're doing is the first one keeps its name, second one gets an IDE ending. Every single one of these is known as a binary compound. Just 2 elements. That's it, just the 2 elements. That's all they got. That's all we need. Okay, so those are all binary. Okay, so the other parts, now that we have the first part of the name, we have done one. We have named it. So every single one of these, notice that has the naming, we've named them. Now we have to decide, does it need a Roman numeral? Does it need a prefix? So one or the other. And so let's talk about that idea of a Roman numeral. If you look at the periodic table, there's certain things that we're certain about. We know that group 1 is going to have a fixed charge. We know that group 1, lithium, sodium, potassium, cesium, all of those are going to have a fixed charge. Okay, so yeah, so lithium, sodium, potassium, rubidium, and cesium all have a fixed charge. We know that those are all +1. I know that group 2 has a fixed charge of beryllium, magnesium, calcium, strontium, and barium. I know that all of those are always going to have a +2 charge. So if I have any of those, I'm done. I don't need to tell my reader anything. There's also another set. If you look across from magnesium, directly across from magnesium, you're going to see aluminum. Aluminum has a +3 charge all the time. It also has a fixed charge. In fact, aluminum and the one below it, gallium, have a fixed charge. And then if you look to the left of gallium, I've got zinc and cadmium. Both have a +2 charge. And then if you look to the left of cadmium, you're going to see silver, which has a +1 charge. So these, group 1, group 2, and that little staircase starting with aluminum all have fixed charges. So whenever you have those present, you simply don't need to tell the reader anything else. You just simply say, if I say silver, I mean +1. You don't need to think at all. We know what ion is present. If I say zinc, cadmium, gallium, aluminum, we know what the fixed charge is. We know exactly what it is, and those are the charges, okay? So in order to name these first two, metal and a non-metal, we're going to recognize anything with a metal, and then we're going to decide if it has a fixed charge, it's done. If it has a variable charge, we have to decide what that charge is. So looking at this first one here, sodium, is that a metal? Yes, sodium is a metal. Is it fixed? Is it in group 1? Is it in group 2? Is it aluminum, gallium, zinc, cadmium, or silver in that little staircase? It's in group 1. So this name is done. This thing just simply sodium bromide. Next up, magnesium oxide. Is magnesium in group 1, 2, or the staircase? It's in group 2. It has a fixed charge as well. So the name of MgO is simply magnesium oxide. Okay, done with that. Next up, iron oxide. Iron is in the D block, which are all variable. And we notice that it is not in the little staircase, right? It's not in group 1, 2, or that little staircase. So I need to identify these two. I need to differentiate these two. I need to differentiate iron oxide from iron oxide. And so we're simply going to do that by knowing the charges of a couple of other things. I know oxygen has a -2 charge, and therefore iron must have a +2 charge, because those two together, the total charge of these, so the total charge from this iron is +2. The total charge from the oxygen is -2. And together, they're neutral. They have to come out to be neutral. So I know that this iron is +2. I am simply going to put a Roman numeral 2 after that iron. Iron 2 oxide. That is basically saying I have Fe2+ combined with my oxide. Okay, the Roman numeral represents the charge of the metal. Down here, I have Fe2O3. Okay, so I know oxygen is -2. I know the whole thing is neutral. I have 3 oxygens for a total charge of -6. And I have, so the iron has to be, together has to be +6. All of that iron has to be +6. So +6, but I have 2 irons that are going to split that charge. So 6 divided by the 2 irons I have gives me a charge of +3. Therefore, this iron has a charge of iron 3 oxide. Again, iron 3 is simply stating that I have a charge of iron 3+. So the name of this is iron 2. The name of this is iron 3. And we're done with that. Next up, sulfur. Is it a fixed charge? Well, first of all, is it a metal? No, sulfur is actually a non-metal. So we're going to come back to that one in just a second. And then finally, calcium. Is calcium a fixed charge? Yes, it's in group 2. So we're done. This is the proper name for calcium fluoride as well. So sodium bromide, magnesium oxide. So we've got all of those names except for S2O3. And so the last part of this, so these are the fixed charges. Should look at those up on the periodic table. And then let's just look at the prefixes. So these prefixes are only for metals with nonmetals. So we're going to go all the way up to 10, 6, 7, 8, 9, 10. Mono, di, tri, tetra, penta, all ending in A's from here on forth, pretty much. Penta, hexa, pentahexa, hepta, octa, nona, deca. So each of these are the prefixes we are going to add. And there's just 2 rules there's one rule out of this list that we need to be aware of. First of all, mono, if the mono never for the first element, so if you have just one of the very first thing on the periodic table, or not periodic table, but for example, if you have something like carbon, 1 carbon to start, you're never going to give it the mono title. I don't ever say monocarbon. If I have, I would say carbon. If I say carbon, I indicate there's 1 carbon there. Okay, and we'll take a look at that exactly. But essentially what we're going to do here is I am going to, whenever we have two nonmetals, life is really super simple. I have two sulfurs. The prefix for two is di. So I have disulfur. And then I have 4 oxygens, and therefore I'm going to use the prefix for 4. There's one exception here. Tetroxide, I'm not going to add the A. Generally, when you have an A run into an O or a vowel, you get rid of it because it just sounds better. If you added the A, it wouldn't be a problem. I would know what you're talking about. But disulfur tetroxide is basically how you would say that. So disulfur tetroxide, we use prefixes when we have nonmetals. Okay, so let's look at a couple more, like just 2 more of these. So if I have one that everybody should know well, CO, CO2, and why don't we do H2O as well? So CO is carbon oxide. Okay, again, we start with just first one keeping its name, second one, and this is also carbon oxide. This one is hydrogen oxide. There we go. Again, first one keeps its name, second one gets an ID ending. All of these we can always start by just writing those out. So if we look at CO, monocarbon monoxide, and whenever we have 2 things running into each other, generally get rid of that second O as well. Monocarbon monoxide, but again, I never write mono for the first one. So I'm not going to write monocarbon, I'll just say carbon, indicating that there's just one of them. If I said dicarbon, that would make sense because there's more than one. This one here becomes carbon dioxide. Everyone should know that. Okay, 2 oxygens present. And then H2O, the proper name, named properly, becomes dihydrogen monoxide. Okay, dihydrogen monoxide. There should be no space between that MON and the O, but dihydrogen monoxide. That's how we name them. Just they get their prefixes with that one exception, no mono for the first one. And that's pretty much it. And then the last thing that I'm going to say is if we are adding polyatomics. Okay, so if I have something like calcium and sulfate, if I have NH4 with oxygen, sure. Let me add NaNO3, NH4, 3PO4. Okay, so in this case, when we have these, same thing is going to hold true. First one keeps its name, calcium. And now I recognize that I have a polyatomic here. If you have a ternary compound, or if you have more than 2 elements present, and I do here, I have calcium, oxygen, and sulfur. So I've got 3 elements. So if I've got those things separate, I have to recognize there's a polyatomic somewhere. So calcium plus SO4 makes calcium, and the second one keeps its name, sulfate. Okay. NH4 is already in parentheses, so when it has more than 1, it's going to get a parenthesis. So NH4 is ammonium, and then oxide. Okay. Sodium and NO3 is nitrate. And then finally ammonium. And I've got 2 here. Phosphate. We're going to treat those kind of like elements. And now we check and see if we need to do anything else. So we never have to worry about polyatomics having nonmetals, but we do have to worry about, are any of these variable charged? No, neither of those are, and the other one's a polyatomic. So I would have to add a Roman numeral in order to tell it, but that's it. We've named all these. Calcium sulfate, ammonium oxide. Again, first one keeps its name, and then second one does. Notice that all of these have changed their names from the IDE ending to just mimic what you have as a polyatomic. So that's pretty much it for all of the naming. Oh, that's pretty much it for all of the naming that we had to do. Okay. And these will be uploaded to the folder. Yeah, so that's pretty much it. And yeah, that's good. We did acid naming in class, but I'm not going to do it here because this video is already long enough.